Hi everyone, I'm going to go through the worksheet. So I'm going to go through all the questions. This video is going to be long, but you can skip ahead. You can also pause it, try it for yourself, and then look at the answer. So for the first one, draw the Lewis structure of magnesium and chlorine. I put the charges here. So magnesium is +2, chlorine is -1. So when I'm writing the formula, we cross them over like this. This gives me MgCl2. So for 1 magnesium, I have 2 chlorines. For the Lewis structure, I draw the Lewis structure of the magnesium first. Then I draw the Lewis structure for both of the chlorines, since there's 2 chlorines. So 7 valence electrons for that chlorine, and 7 valence electrons for this one. To show the transfer of electrons, I'm going to use arrows. So this one is going to transfer here. This one is going to transfer here. That's all you have to do for the drawing the Lewis structures. And then the name for this is magnesium chloride. Okay, let's try number 2. So I've got magnesium and sulfur. So the first thing I want you to do is write the charges at the top, like I did here. So magnesium's +2, sulfur is -2. And then I want you to do the crisscross. So let's do the formula first. So I've got and sulfur. We cross them over, we get Mg. So it should be Mg2S2. But remember, when the numbers are the same, so 2 and 2, we drop it down to 1 and 1. So my answer should be Mgs. So 1 magnesium, 1 sulfur. Again, remember that the 1 is imaginary. So I'm going to cross this out because I want to keep it like this. So I have 1 magnesium and 1 sulfur. Magnesium has 2 electrons. Sulfur has 1, 2, 3, 4, 5, 6. I'll use another color for the transfer. So this one is going to go here, and this one is going to transfer here. So we just represent the transfer, draw in arrows. And then the name for this would be magnesium sulfide. Okay, next one. My potassium +1, fluorine -1. Potassium +1, fluorine -1. I cross them over, and I get KF. So 1 potassium and 1 fluorine. Potassium has only 1 valence electron. Fluorine has 7. Potassium loses its electron, it goes to fluorine. Now fluorine has a full outer shell of 8. The name of this would be potassium fluoride. Okay, let's do the Lewis structure for this one. So potassium, +1, oxygen, -2. Cross this over, cross it over. We drop the signs and we get K2O. So that means we have 2 potassiums, 1 oxygen. So potassium, potassium, and they both have only 1 valence each. And then oxygen has 6. So 1, 2. This potassium transfers its electron here, and this one comes here. So we draw the transfer with the arrows, and that's all you have to do for the Lewis diagram for that. And then the name of that would be potassium oxide. Okay, this one here, beryllium has a charge of +2. Nitrogen has a charge of -3. So the formula unit, we've got BeN -3. We cross them over, remove the signs. So I've got Be3, N2. So that means I have 3 berylliums. Each one has 2 electrons. And then I have nitrogen, 2 of them. Each one has 5. And this one has 5 too. So each nitrogen needs 3 electrons. So that first beryllium will transfer 1, 2, and then this beryllium in the middle will transfer over here, so 3. And then this nitrogen now needs 1, 2, 3. So now this one has a full 8, so you can count 1 arrow, 2, 3, 4, 5, 6, 7, 8, and that's the same with this nitrogen here. The name of this beryllium nitride. Okay, this one here, calcium is +2, phosphorus is -3. When we cross them over like this, we've got 3 calciums, 1 phosphorus, and it will look just like the other one did. So we've got 2 electrons here, 2 electrons here, and 2 for our last. Phosphorus, phosphorus. So phosphorus needs 3. So I have 1, 2, 3. So that's my 1 phosphorus done. And my second phosphorus, I've got 1, 2, 3. With the name of this being calcium phosphide. Okay, let's continue on to this page. So my aluminum is +3, fluorine is -1. So I cross them over. I get 1 aluminum and 3 fluorines. So I'm going to write aluminum, which has 3 valence electrons, and 3 fluorines, which each one has 7. Okay. Then aluminum, so each fluorine just needs 1. So we'll send this one to this fluorine, this one to the middle fluorine, and then the last one to the last fluorine. The name of this would be aluminum fluoride. Okay, now number 8. So calcium is +2, iodine is -1. Cross them over. We get CaI2. So we've got 1 calcium, which has 2 valence electrons, and I've got 2 iodines. So I've got, and each iodine has 7 valence. So calcium will send 1 to this iodine. Since each iodine only needs 1 more, this calcium will send it to this one. And we gotta write the name, which will be calcium iodide. Okay, number 9. Rubidium is +1, oxygen is -2. Cross them over. We get RB2, and then just 1 oxygen. So we've got 2 rubidiums, and they have only 1. And then my oxygen has 6. So 1, 2, 3, 4, 5, 6. This one will send it here, and this one will send it here. So then rubidium oxide. Okay, now we have strontium and fluorine. So strontium is +2, fluorine is -1. So we've got Sr +2, fluorine -1. We cross them over. We get SrF2. So 1 strontium, 2 fluorines. So 1, 2. And then fluorine, each of them has 7, so 1, 2. So this electron gets sent here, this electron gets sent here. So fluorine has a full 8. And this is strontium fluoride. Okay, let's do number 11. So aluminum is +3, chlorine is -1. So aluminum, we're gonna cross these over, and I've got 1 aluminum, 3 chlorines. So aluminum, 1, 2, 3, and then 3 chlorines, which each one has 7 valence. One, 2, 3, 4, 5, 6, 7, and then aluminum is going to send each one to each chlorine. Okay, and then the name of this will be aluminum chloride. Okay, this one, magnesium, +2, phosphorus, -3. Formula unit, cross them over. Oops, Mg3, P2. So I've got 3 magnesiums. 1, 2, 3, and 2 phosphorus. Phosphorus has 5. Magnesium has 2 each. So that first one, we'll send 1 to the other side of the phosphorus and here. And then the middle magnesium is going to fill it up, needs just 1 more. And then the other phosphorus, I'll do this in another color, we'll take the other leftover electron in that magnesium, this electron, and this electron to fill up phosphorus so it has a full 8. And then the name of this is magnesium phosphide. Okay, then I've got boron and oxygen. So boron is +3, oxygen is -2. So the unit. So the formula unit, that's just writing the formula for it. So I've got 2 borons and 3 oxygens. So boron, boron, each one has 3. And then I have 3 oxygens, 1, 2, 3. Each one has 6. Run out of space here. Okay, so boron, the first boron will send 2 to the first. Then its last one will get sent to the middle oxygen. Then the other boron has to send another one to that middle oxygen to fill it up. And then the last 2 goes to the final oxygen. Giving me boron, boron oxide. Okay, and then the last one, beryllium and sulfur. Beryllium is +2, sulfur is -2. Cross them over, I get Be2S2. Remember, if the numbers are the same though, we can drop it down to 1 and 1. So this is not going to be my answer. It's going to be BeS. So 1 beryllium, 1 sulfur. So beryllium, which has 2 valence, then sulfur, which has 6. Beryllium will send 1, 2 over, with the name of it being beryllium sulfide. Okay, now we'll work on the sheet. So number 3, aluminum, so is Al, and then phosphide is phosphorus, which is 3 minus. Okay, so I'm crossing them over. So this is going here, this is going here for the formula. So I originally will have Al3P3, but again, since the numbers are the same, I will write it as ALP. So we'll cross that out. This is the final. So 1 aluminum, 1 phosphorus. Next one, magnesium. It's 2 plus, oxygen is 2 minus. Cross them over. We get Mg2O2. Numbers are the same. We'll drop it down to MgO. Okay, then we've got cesium fluoride. Cesium is Cs1 plus. Fluoride is 1 minus. Cross them over, we get CSF. Then strontium is 2 plus, nitride is 3 minus. Cross them over, we get 3 strontiums, 2 nitrogens. So for the rest of this one, I will finish it off and I will upload a picture for it. Let's just do some of the polyatomic. So I had to add chlorate to this because there is one with chlorate. The first one, so NH4, we know that's ammonium. So I'm going to write ammonium. And then it's just chlorine by itself. But since it's we're doing an ionic bond, the nonmetal has to be the IDE ending, so it's chloride. Okay, we've got beryllium, so we'll write beryllium first. Okay, and then SO4. So I'm going to look up here at SO4, and it's sulfate. Well, there's a 2 charge, but what happens is that, I'll do it over to the side, since beryllium has a charge of 2 plus, and sulfate has a charge of 2 minus, when they cross over, they're going to cancel each other out since they're the same number and become 1 and 1. So that's what we have here. So this is beryllium sulfate. Okay, this again, we've got ammonium. And then nitrogen is nitride. Magnesium, chloride. Okay, we've got ammonium again. And then NO3 at the top we know is nitrate. So ammonium nitrate. So I know I said that you can drop the brackets if there's imaginary 1, but you can also leave the brackets. If the brackets help you, you can leave it there. When you leave the brackets, you can then see what the cation is and what the anion is. So the next one, this is strontium. So you can always just go ahead and write the metal. And then PO4, that's phosphate. So strontium phosphate. For number 7, we're just going to leave that one. Then number 8, that's potassium, so I can go ahead and just write potassium. And then Cr2O7, if I look over up at the top, Cr2O7 is dichromate. So then I would just write. So this is the one where I had to add it, so the one highlighted here. ClO3 is chloride. So this is gallium. Chlorate. Okay, the next one. You will see this is a transition metal. Since it's a transition metal, it will have a charge. So let's do the reverse crisscross, and I'm going to do it over to the side. So CuOH. You'll see the imaginary 1 here, the imaginary 1. I'm going to reverse the crisscross, and you'll have Cu 1 plus, OH 1 minus. We then have to check to see if the anion's charge is correct. So we got to see if this charge is correct. So we could look to the top, and we'll see that hydroxide at the top actually is OH 1 minus. So this is my charge for copper. So I'd write this as copper (1) hydroxide. Okay, my next one, that's ammonium, so the NH4, and then PO4, that's phosphate, so I can just write ammonium phosphate. Okay, iron, transition metal, let's move to the side. So Fe, what is it? FeSO4. So imaginary 1s, we reverse the crisscross. This becomes Fe1 plus SO4 in brackets 1 minus. Now we have to check the anion to see if that charge is correct. So we go to the top and we'll see that sulfate actually has a charge of 2 negative. So what that means, in order for them to drop 1 to 1, that means that iron also had to be a charge of +2. So it'd have to be iron 2 plus and sulfate 2 minus in order to drop to 1 and 1. So when I write it here, I'd go iron 2 sulfate. Okay, magnesium, we can just write it down because it's not a transition metal. And then NO3 is nitrate. We got ammonium again. And then we've got NO2. So NO2 is different. NO2 is nitrite. Na, this is sodium. And then Cr2O7 is dichromate. And then the last one, we've got sodium again. And that's hydroxide, so sodium hydroxide. And that's it for this worksheet.